Hello and welcome to SciJoy. Today we're going to talk about buoyancy. Let's say you are a bird that has to traverse through a weird set of pipes, but instead of flying through them, we stuck you underwater in a sub that propels you forward. You're a pretty dense bird because you're so muscly from all your flapping, so by default, you and your sub sink. But don't worry, we gave you a nifty little feature where you can increase and decrease your ship's volume. But how does this feature help you? The Earth's gravity is pulling you and your sub down to the bottom of the ocean. The water is using something called a buoyancy force to push you upwards. The buoyancy force doesn't care how much you weigh, it only cares about your volume. You can see that each of these 1-inch cubes has a different mass, but since they all have the same volume, they each displace 16 grams of water when they're fully submerged. If we put 2 of these cubes together, you can see that they're going to double their volume and double the amount of water they displace. Let's see what happens to your ship when we increase and decrease its volume. You and your ship have a mass of 1,500 kilograms. We saw when your ship was small, the buoyancy force was less than that of the gravitational force, and you sank. So when your ship is a medium size, the buoyancy force is the same as the gravitational force, and you're neutrally buoyant. This means you can just cruise along in a straight line. To rise up to the second set of tubes, you will need to increase your volume so the buoyancy force is greater than that of the gravitational pull. If you allowed your ship to stay at the largest volume, the buoyancy force would push you out of the water. Since the equation is balanced when 1,500 cubic meters of your ship is underwater, the buoyancy force will push you until the other 500 cubic meters is above the water line. But let's get back to the game. To get you through, you'd start out with a medium ship, then you'd switch to a large one, and then you'd drop down to the small ship. You have a small bird friend, and when they get in the ship, they have a combined mass of 950 kilograms. This means all 3 ship sizes would float. So we have to have a different sub with a ballast tank for them. This means your bird friend can add and remove water to weigh down the ship. But how much water does your friend need to add to get to each set of tubes? For the first set of tubes, you will need to add 50 kilograms in order to be neutrally buoyant. Then you need to purge all the water in order to float up to the second set of tubes. To sink down to the third set of tubes, you will need to add over 50 kilograms of water. You and your bird friend are getting pretty good at all of this, so what if we put you in a sea of vegetable oil or one made of molasses? What would change? Can you and your bird friend navigate through these new seas? Thank you for watching this episode of SciJoy. If you have any questions or comments, leave them down below. You can also find us on Twitter, Facebook, Instagram, and Tumblr. Click on one of these side videos to learn about our robotics project, and remember, keep exploring.